Hello guys, my name is Yang, and today I'd like to introduce my solutions to problem 2 in long homework 2. And let's first see the section 2.1 and solve the homogeneous equation. Solve the two homogeneous equation in the regions away from the delta function spike. And the two homogeneous equation in this, we know this is the second derivative equation, and the solution for this equation is easy. This is the motion with no acceleration. Because this is respect to x, we can write directly the solution to g x y equals to, because this is by piecewise, we write it by piecewise. G less than x y equals to let's just say ax plus b for in 0 less than x less than y less than 1, g larger x than y equals to cx plus d in 0 less than y less than x less than 1. So we write these solutions with 4 underdetermined coefficients. How to get these coefficients? We first impose the boundary condition to this, and we get, and this for the boundary, we know this is a boundary from 0 to 1, and the left boundary is x equals to 0, and the right boundary is x equals to L. And we just insert these two these solutions. We get g 0y equals ln to because the x is 0, 0 is less than y, and we show that from this a plus 0 plus b equals to b, and we get b equals to 0. And the next condition is g L equals, from at this L equals to 1 and 1 y equals to 0, and we get say multiplied by 1 plus d equals to 0, and we get d equals to minus c, and we get and then this is the boundary condition, and then we need to use the continuity for x equals to y. That is the equation g larger and y is equal to g larger y, and we get a y equals to c y minus 1. Okay, this is the first solution, and we get 1, 2 under determined coefficients, and there is also 1 equations for these two underdetermined equations, so the total underdetermined coefficients is 1. And next we solve the section 2.2 patching part 1. And this is for fixed y, integrate the green function over an infinitesimal silver x. Maybe useful to remember that this one. Okay, we just use this one to insert to this equation. That is use this. That is g dot g that is y equals to, and this is the delta function. We know that is 1. So, and this we know this is dg dx, and dg dx y plus epsilon, that is x larger than y, y minus epsilon y is x less than y. Recall we saw the solutions in the section 2.1, that is g less is ax, g larger is cx minus 1, and that we print here. That is this g prime is as to a, and this g larger prime is to c, and we plug it here. That is x larger than y, that is c, that is c minus a equal to 1. Okay, and we plug this into this form. That is c minus a equals to 1, and c equals to 1 plus a. Get ay equals to 1 plus a. That is a equals to 1 y minus 1, and c equals to a plus 1, that is y. So we got the answer to this to underdetermine the solution, and we get g x y equals to g less than x y equals to, and a is y minus 1, that is y minus 1 x g larger equals, and the c is y, so we get y x minus 1. Is that correct? In x in okay, this is the final solution for g x y, and let's and write out the resulting equation in terms of g at. You will find that the slope is continuous, so we can get that yes, this is the slope, and this one, the discontinuous at x equals to y is 1. This is discontinuous. And the final 2.3 section, patching part 2, integrate 7 again, or 7. Let me have a look. Integrate this again. This is the second derivative and the first order integration, and then let's then do the second order integration. And that is for the y plus epsilon, y minus epsilon, and d g x y dx dx is equal to, we need to do this in 2 sections, and the first section is because there is a spike at x equals to y. The spike and the derivative function. So we need to x y minus epsilon y and dg x y minus y plus epsilon dg x y equals to g x y plus epsilon y, and that is, we just take these two things into the equation, okay, and that is, we see is g minus is g larger. We see that equals to minus epsilon, and we know for the first thing is simply discontinuous, and we need to know how the zeroth derivative is continuous. That is limit epsilon g y plus epsilon y minus g y and less epsilon y is equal to this one. So this one is to 0. So we get that for the zeroth derivative, this is continuous. Okay, and part 2.4. Take all the above results and write down the piecewise definition of green function in 6 as explanation of coefficient determined sketch for y equals to 0.5 and compared to the first series solutions. And for this section, the green function is we derived it before, equals to y minus 1 x and y x minus 1 in, and we set a y equal to 2.5 to compare it to the first series solution. And the first series solution is from problem 1 we have solved before. Let's first write the y equals to 0.5, that is. Okay. And the gxy is for the first series solution is equal to 2 sine that is pi x sine pi y divided by square pi square minus k square. And if we want to plot this function, we need to use the math software, and we can plot this function and compare to this. We get, sorry for the delays, we get, okay, get this plot, and the exact result is this one. For the x equals to 1/2, and the left is maybe I was wrong. Okay, it seems like that this is minus sign, and here the left, the professor maybe forget this minus sign, so this is minus 1, and this is minus 1, minus 1, minus 1, and minus 1 is minus 1 plus 1. That is a equals to minus y plus y, and c equals to minus y. And here with that is minus, and this is minus. So here is minus, minus, and this is plus, and this is minus. So this is 1 minus x, and so, and we can see the exact solution is the black line. This and we can see for the n order series, we see that if m we increase m, and we can show that the solution of the series approximation is approximate to the exact solution. This is the right answer in mathematics. Thank you very much. And there is no, due to time limit, there is no time for the section 2.5. Thank you very much.